All right, so we are starting parametric constraints today. Constraints, we've covered quite a few in Inventor, and so I want to review those first. We have used numeric constraints or dimensions to force like our sketches and lines to be a certain size. We've used geometric constraints to force relationships on the lines that we've drawn in our sketches. And we've used assembly constraints to hold parts together within an assembly file. And the fourth type that we're going to use and talk about today are parametric constraints. And the idea is it relates to dimensioning, but in a way that we're going to create formulas that create a relationship between the different parts of our sketches. So let's use a chair as an example. If I were to design a chair in, let's say, like the chair that you're sitting in now, the feature that I would base all my other dimensions on might be, let's say, the height of the chair. So the distance from the ground to where I'm sitting on the chair. In fact, let's look at, let's say, an Adirondack chair as our example. Okay, I'm designing an Adirondack chair to sit in. I'm going to use formulas to create a relationship between the height of the chair and all other dimensions. That way, if I want to design the same chair that is for a child or someone smaller, I change the one dimension being the height of the chair or the height of where the seat is, and everything else scales based on that one change. So we're going to use formulas within Inventor to create parametric relationships between the different parts of our sketch. And although it sounds very complicated, it's actually fairly easy and has been doing this in Inventor the whole time. So let's look at an example in Inventor. I want to build a puzzle cube piece. Let's say it's like an L-shaped piece that is made up of 4 of the cubes. So I'm going to draw then the L-shaped piece, and I'm just kind of rough out the size, and then I'll go back and add dimensions to the drawing. Okay, so that's kind of the L-shaped piece that I'm going to be working with. When I place the first dimension, let's say it's going to be this height right here, notice that above the dimension it says edit dimension D0. D0 is like my starting dimension. And for this, I'm going to set an actual number of 0.75. Now the rest of the dimensions on this drawing are going to be based on my D0. So when I place a dimension for the width of this object here, I'm going to make this not a number, but my D0 times 2. So I get 1.5, which is the number I want, but I get the f of x, or a function, so that if I change d0, this will change automatically as well. I'll do the same thing for the height. I want the height of this to be 3 times my d0, or d0 times 3. I'm going to set this to be equal to d0, so if my d0 numbers, or the 0.75 changes, excuse me, I did do, you make sure it's D0. So that if this dimension changes, so will this as well. I'll finish my sketch. And when I do the extrusion, I want this thickness to also be equal to D0. And hit OK. So I built this piece parametrically, so that if I change my D0, or I change some of the other variables, it'll adjust the piece as well. If you go into the Manage tab and you look at the parameters, it keeps track of all the steps. Okay. Let's say I decide to change the size of this. Let's say I order cubes and they're not 0.75, they're 1. I'm going to change that number here. Notice that the piece gets larger, but everything stays in proportion. Okay. So that's the idea behind these parametrics. So for today's activity, if you download the activity sheet from the LMS, 8.2, we're going to be building this plate here. All the dimensions have already been placed on this. It's really important that we follow the dimensions as listed on here. Right? This dimension has to be D0. This overall width has to be D1 on this activity. So we want to follow in order using this as our guide. If I scroll down, it'll give you basically all of the descriptions for the sizes. So my overall plate depth is going to be D0. Overall plate width is a function of that, 5/3 the overall plate width. And so I'm going to D0 times 5/3. Some of them have been given for you as far as the equations. Some of them you need to figure out on your own. Okay? Note that when we do an extrusion, and we can go back and look at my example, when you do an extrusion, it uses more than one parameter. So the extrusion is how far you want to extrude plus the taper angle, which typically is set to 0, so that it extrudes out straight, but you could change that. So note that when you do an extrusion, it's going to use up 2 parameters. So don't feel like, oh, it skipped a number. It didn't. It just used 2 to do the extrusion. Okay. Back to the activity sheet. Beyond this, there's also step-by-step directions, kind of showing you, okay, I'm going to sketch the rectangle. I'm going to set this to my D0. This is D1. And then I'm putting in all of the formulas that I need to create this object. A couple things. Make sure that when you're doing this, you're using like the slot feature to create this. I can't just draw a rectangle and 2 like arcs on either side and get this to work and follow these D numbers. Okay, so it has to be a slot. Make sure you're using like the circle, when you do this. And again, make sure that you're following in order the dimensions as is listed here. When you finish, you should be able to go back into the parameters and change your D0 and have everything shift, but stay in proportion. Meaning, if you change your D0 and this shifts somewhere else in the drawing, there's probably something wrong with one of your formulas. If everything scales up to a larger size or scales down depending on what your D0 is, and everything is still in proportion, then you've done it correctly. Okay? For this activity, I want you to finish building this plate, take a screenshot of that plate in Inventor to show me what you built. Take a screenshot of your parameters. So go back into Inventor, take a screenshot of this with all the parameters that you used to create this. So you'll put each of those onto a Word document. There's also conclusion questions in the activity that have to be answered, and then all of that can be submitted on the LMS. So 2 screenshots, your conclusion questions, submitted to 8.2 on the LMS. I'm going to give you today and tomorrow to work on that, and then we will move on to Unit 6 when we get back from our 3-day weekend.